Yeah, good. Cool. Today I want to do something that's fitting for yesterday's release of Neo4j. So yesterday Neo4j 4.1 was released, and there was a blog post somewhere here. Blog post from Ivan and Pat talking a little bit high level about Neo4j 4.1. So the main changes were around security improvements, some clustering improvements, especially for like production level systems, and query planning, which I'll look into, memory management, and some other stuff which they didn't mention. So, and we will mostly look at the stuff that they didn't mention because I find these things really cool. And so what before we start, I want to show you some of the things that we put together for 4.1. So for once, our engineers that worked on the different features took some time and talked a little bit about those. So if you want to have like live engineering takes on the features they built for 4.1, you can go to YouTube. I also put the list into the chat and into the video and see these short takes here. They're all between like 5 to 10 minutes, I think. So it should be really quick to watch them, and you see like first-hand information from that. The other thing that's really nice is in the release notes. Yes, release notes. Here's the release notes. In the release notes, it's also a little bit more detailed for things that are important. So for instance, database privileges for transaction management is really interesting. So we look at some of those going forward in this session. So I'll use this a little bit to guide me and I don't forget stuff. There are two things that are not in here, which I'll show you probably at the beginning, so we don't forget about it. And it's also linked in the list. And then the other thing that I wanted to show you is on our developer blog on Medium, we have already like 2 blog posts or 3 blog posts more or less about some stuff around Neo4j 4.1. So role-based access control, Adam did a blog post about that, Lou did one on the Python driver, and Nigel a few days ago did a post on the new Go driver, which is pure Go and not based on the C library anymore. And there's more stuff coming. So Jennifer put together an Neo4j graph database section in the developer guides, which with some more detail. And then for each of the versions, we're collecting basically more detailed blog posts and articles in each version. So you see, we already have the first few things here, and there's she'll add more to that as well. So watch this space. Something that Mark put out is a first how-to for memory management feature in 4.1, and he explains a little bit how this works and what it does. So if you want to read up later about it, then we can do this. Okay, and there's of course also the detailed engineering changelog, which has more details on specific improvements and fixes and so on. So it's more comprehensive and definitely a resource to look at if you want to go into details. Okay, cool. But now without further ado, let's get started. So there you have several options getting Neo4j 4.1. So you can go to Neo4j download or download center and either download Neo4j Enterprise 4.1 or Neo4j Community 4.1 directly to run as your database on your system. I'll work with desktop today, which also supports 4.1 as of this morning. And of course, you can also use RPM and where are they? RPM. There. So there should be also RPM packages for Neo4j itself. So if you go to yum.neo4j.com or to debian.neo4j.com, you find information for installing Neo4j 4.1 here as well. And we can check if Docker is updated, because that always takes some time for the Docker folks to update stuff. And it seems latest enterprise 4.6. So it seems that we are still waiting for Docker to update the official image. So that's unfortunately not yet possible. But I think it's a few days or so latest until that's available. Okay, but we will use desktop. So I use desktop Canary because this morning it didn't work yet, but I'll show you. Let me just stop this one and delete it so we can start from scratch. So if you want to use 4.1 in desktop, you create a local graph. I just call this 4.1 test, give it a password, and you can see you have 4.1 in the drop-down list here. I already downloaded it, so it doesn't take so long. And then we start our new graph, create our new graph. And fortunately, Mark did also a release of APOC for 4.1, which is, APOC releases, which is already available in Neo4j desktop as well, as I just checked this morning. So this was like 20 minutes ago. So we're really bleeding edge. And with 4.1, something changed. So we added another distribution of APOC, which is called APOC Core, versus the current APOC All that we've had for all the time. And APOC Core will be bundled with Neo4j 4.1.1. So it didn't make it into the GA release, but in the first patch release, the 4.0 Core jar for APOC will be bundled in the binary distribution of Neo4j, so you don't have to go and search for APOC releases that fit your Neo4j installation anymore, if you want to use that. So desktop has created our database, and now we can go and manage, look at plugins and install APOC here, which is really great. Thank you, Mark, for making this possible just in time for my for my live stream. And I just realized that I didn't plug in the headphones, so the sound is probably a little bit shit at the beginning. Hope that's better now. So we have APOC installed now, and let's just up the memory for this database a little bit. So let's say we have 4 gig heap and 1 gig page cache. We apply this, and then we start our database. So there's a ton of features to look at. Let's see what we can cover in these remaining 50 something minutes. I'll start with some Cypher features and some database routing features, and then we go into more detailed stuff later on. Cool. So waiting for this to start. I just need to remember not to forget stuff that I want to show you. So APOC releases we don't need anymore, Docker we don't need anymore, download we don't need anymore, developer blog, watch this space for more articles, memory management, we'll look into this ourselves. There's a slideshow, so what I want to look at is the changelog and the release notes, so we don't forget about stuff here. So okay, actually let me steal some stuff from Adam's blog post just in case I forget something. Okay, database is started. We can now open browser. If you haven't used this before, you can press just Command K and Control K to get a command bar inside of desktop. So again, it's Control K or Command K, and which allows you from everywhere to start every kind of thing. So graph apps, but you can also start stop databases and things like that. And also you can find the desktop log files, or can open different graph apps. So we wanted to start browser. Okay, so we have browser connecting to our 4.1 instance. So we should also see if we open this here. That's Neo4j 4.1.0 and browser 4.0.11. So first of all, the one feature that's new, which is super helpful, is if you remember in 4.0 you could create databases and stuff. And you always had to switch to the system database. You always had to use system and then do these things. So this is now handled by the database router. And I can just somewhere create database movies, and then if we just redirect this to the system database, and now we have a database movies here, right? Something else that so I can also run show databases, right? And then what's new actually is that these show commands can do some more stuff. So with yield, you can select which columns you want to see. For instance, name, current status. Oops, current status. So you can select columns, but you can also say where name starts with M or contains O. Name contains O. And then you can also, if you want to do, and then do a return. Oh no, okay. The return was just me imagining things. So, but you can do filtering and column selection for database commands. So, for instance, if I say show roles or something like that. Oh, it doesn't have a current status. What? It's probably called role. Role as name. Does this work? No. I hope role is there. Yeah, so editor has an O, right? So, and if I remove this where I see all roles. And if I move the column filtering, then I see all fields of roles. And remember, I'm still at the Neo4j database, right? So that's kind of really cool. Oh, which also shows us there's a new role called public in 4.1, which is automatically assigned to everyone. So it's available to add permissions to, for instance, if you want to have the public role has usually only access to the default database and nothing else. And if you want to change this, you can put other information on the public role as well, which is really nice. So that was one thing. So we created a database, we created a user, and the other thing that's new, we did the filtering of columns for show commands. And the other thing that you can do is now basically give more granular permissions for writes, for instance. So you can say grant write on name to role public or something like that, right? I have to sneak into Adam's blog post because I can't remember something. Write permission. So for instance, you want to do grant match and then grant write. There's write. Ah, here. So access to the database, graph databases. What's also new is management and privilege access as well. You can control this as well. And there's also index management and constraint management. So you can say, okay, only certain people are allowed to create indexes constraints or create tokens, for instance. Name management is like labels, relationship types, and property names. So you can restrict who can create stuff like that. So they don't mess up your database schema. And then what's also cool is transaction management. So you can say who is allowed to list and kill transactions on a database. So for instance, if you want to do this here, we can say to public. So our public user can do transaction management. So if I do, for instance, call dbms list transactions. Come on. So you see it's really a Whirlwind tour. We are going from A to B to C. So it's so these are all the transactions. And here's something that I want to go into a little bit later. But what I actually wanted to see is this write permission. Where do we have grant write? grant match, grant traverse, grant traverse. Here, sorry. The difference is you don't grant a write permission as such, but you grant a permission to create a node. You create a relationship or update a property. So for instance, if I say, if I have my graph here, create graph, create database, Whirlwind, create role, north, our graph. So this website user, we don't have currently website user, create role web. And then we basically can say this website, the people in this role website user are allowed to create nodes with the label order on this database, right? Or we can say create grant set property, for instance, right? So then it can, and then we have to say which property. For instance, we can say only the quantity property can be updated basically by the website user, right? So then they can't write any other property basically, right? They can create an empty node, people in this role, but they can't set the other properties than this one. Okay, so if you want to learn more about all this permission control stuff, please have a look at Adam's blog post and the documentation. That's most that I want to say about this. What I find much more interesting is this memory management thing. So to make Neo4j more robust in terms of memory usage, we added much more memory tracking into Neo4j. So for instance, if we create our movie graph, play movies. So this is a really tiny graph, right? And we can just use this for examples. And what we can do now, if we run queries here on this graph, so for instance, if I just find all people, return count star, and then where name starts with, T or so, to count star, person.name. So this is a regular query, right? And doesn't return a lot of data, but if I run this now with profile, you see that there's a new field in the profile output, which is called memory in bytes. And so some of the operators have memory allocation assigned, and the final operator also has like total memory of the query. So this is like 74 bytes. It sounds really little, but because it pipes data through this query plan, it basically just needs certain data structures to hold the data, and then there's no additional data structure memory needed. So I don't think it kind of tracks memory that's accumulated as part of like operations, where it kind of creates objects on the fly and stuff like that, but at least the data structures that are created are taken into account. And this is actually also something that you can see in Cypher shell. So if you open a terminal here to our database, so bin Cypher shell user Neo4j password test, then we can also run queries with profile and see the output of that. So for instance, if I do the same person where p.name starts with t, return counts down. You also see this in the profile output here. Which takes us to another thing, another detour. So besides the memory usage, we also have much better coverage in the pipeline runtime. So the pipeline runtime is now almost possible, can do almost all the read queries. And that gives you quite some performance benefit, especially for more complex queries. It's also possible to it partially compiles queries. So for instance, it compiles expressions like this p name starts with t. If the queries run often enough, this will also be compiled. And if you want to play around with this, you can also say Cypher expression engine compiled, and then it compiles them guaranteed, or there's also compile when hot. And there's also, if you want to play around with other stuff, Cypher runtime parallel, which is still experimental. That's why it's not documented yet. So don't rely on this. But what's also cool, what you see is the engineering team improved the output of the profile in the shell. So it's much more readable now and has the memory information. And in details, you have all the stuff that you need to know. And this gigantic variables column is gone and has been replaced by details. And there's some other information on the left side, on the right side. If you have a more complex query, let's say we go to a movie and then return, let's say p.name, p.age, comma, and then collect m.title. So you see it gets bigger, but should still fit onto the screen. I just increased the font size. That's why, after starting the shell, that's why it didn't fit. But that's really nice as well. So that's another improvement. So parallel runtime, pipeline runtime. So actually, we should only use pipeline runtime. There's still slotted runtime. So so most of the all of the write queries are slotted runtime, and some read queries are also slotted runtime. Okay, that's that. Memory management. What's interesting about memory management, if you look at Mark's article as well, memory management, you see that you can now configure in Neo4j config how much memory a single query is allowed to take. Right? So we see this is kind of the memory that the query takes with the different operators. But now you can basically say, I want to limit this. And I can, for instance, say per database, per globally, and per transaction. So for instance, if I set in our config, let's try this. I've not done this before. So let's say each query is not allowed to take more than 4 megabytes of memory. So we apply this change, restart the server. And so we can set this here. The other thing that's new is that there are some procedures that show you like memory usage in Neo4j across like all the database with list pools, and then in list transactions and list queries you also get more detailed about like allocated bytes and things like that. So you might have seen this just now. So is it restarted? Not yet. Let's see. So so that's what I want to try as well. So I actually want to try to create a query that aborts. Let's see if this works. Still restarting. Metrics started. So okay. So this is a really simple query which doesn't take a lot of memory, but if we, for instance, now say we want to create some cross products, Hopefully this will take some more memory. Let's see. No. We don't have enough data in our graph, so we just create some data. Let's do this. Call epoch periodic iterate, and we just create 1,000,000 nodes or 10 million nodes. Unbind range 1 to 1 million, 10 million SID, and then we just create foo is related to itself. Return ID. So, and while it's okay, sorry, batch size 10,000 or 100,000. I don't run it with parallel, so OBS does not die on us. Okay, so it creates some data, and while it's doing this, shouldn't take too long actually. I want to look at one of the other features. Oh no, let's not get too distracted. So you see kind of different operators have different memory information, and actually this is interesting. I thought there would be much more memory used by like this Cartesian query, which is really interesting. Why does it actually return 0 rows? Oh, because I was not in database movies. That's the reason. That explains it. So if I run our profile on our this profile again. Oh, this looks much better. Right. So we see now there's more data, and we create 17K, and so by just adding more more dimensions, actually should not use movies but person, because there are some more people in there. Person. So let's see if this exceeds our 4 megabyte memory limit or not. So this, oh, see, our interesting, our create query was killed. So our create query was killed because the memory limit was kicked in. Okay, that's a little bit unfortunate. So something that's on my wish list for Neo4j is that there should be separate memory limits for read and write queries. Let's see. By the way, if you have any questions or if you want to go into detail into some of these things, let me know in the chat, and I can answer that. Currently this cross product is still running, because I'm not 100% sure that the in-flight memory tracking is 100% there, but let's see. But our nice epoch statement was killed. So what actually happens if we use a smaller batch size, let's say like 100, and we only create, let's say 10,000 nodes or so. 10,000 nodes. Okay, this succeeds, right? So it basically depends on the batch size, how many nodes at a given time do we create. So let's see if 1,000 also works, and if you do 10,000 nodes in one transaction, that fails. So you see like 10,000 nodes creation would take more than 4 megabytes, but 1,000 nodes would still work. So that's also good kind of to control, especially create queries, I think, more than the read queries, because you see that the read query is not really killed, right? Despite it probably going it out of memory. So you see that it's actually doing in 1.4 billion Cartesian product, right? Which is probably a little bit much. So I'll kill it manually. Okay, so that demo did not work so well. So I'll have to go back and see what we can do there to improve. Actually, let me see if I reduce the cross product to only 4 levels. Oh, sorry, not with explain, but with profile. That's only 89 million rows, right? So that's, oh yeah, there it goes. So you see that the memory estimation is really low, but the number of database operations is quite high. So that's interesting. How many DB hits? So DB hits is actually also not so much, but the runtime was pretty high, right? 13 seconds. So anyway, that's something that I guess we need to look into. So something else that's really cool and that's new is correlated subqueries or subqueries. So subqueries in general already were in 4.0, so you could already do something like call match movie return count star as count, and then you could say union or no, sorry, what I wanted to do is this here. Right, person. So it basically does union gives us the two counts, right? But we couldn't do like sorting by count anymore, right? So because if I sort by count, then I only sort each query individually and then not the full query. So what I could do in 4.0 already is like a subquery like this. And then say return C order by C descending or something like that, right? And then it's the other way around. Or I could say with C where C greater than 100 or so, right? So this is basically subquery just taking a query pod, and whatever comes back from this query pod can then be processed further. So that was already in 4.0. But the problem was you couldn't use stuff declared here before, right? So you could say, could not say with, let's say, 42 as answer. I could not use the 42 in here, right? So I couldn't return this because it basically said, okay, I can't access this thing, right? But with for one subqueries now can access outside variables. So if I just add a with answer in the beginning of the subquery, it should call with answer union or. Oh, that's actually a good question. If I have to put it in both. Interesting. That's actually something I have to figure out. Anyway, so imagine we remove this union all here just for the time being, and the where clause. Then it should be able to access this variable as well. Let's see if this works. Does it? Oh, right, we have to rename whatever comes back. So, okay, so we have A2. So there are some limits to this. So first of all, you have to declare what you kind of have. And then if you return something that's already in the scope of the auto query, you have to rename it first. So this is kind of a contrived example, of course. So let's use a proper example. So imagine we had these people here, all these movies, and we wanted to return the cast of each movie, right? So there is kind of the option of saying, I have a person who acted in a movie, and then say just we return movie collect P as the cast for each movie, right? Or we can just say p.name and movie.title, right? So that was the first version, basically, which doesn't expand and then collect, but which gets more tricky if you have like multiple subtrees that you want to go along. So a while ago in 3.1, I think Andres added pattern comprehensions, which is also something that we use a lot in GraphQL and in Spring Data Neo4j. And a pattern comprehension is actually quite cool because it's like a subquery, right? So I can just say with this thing where, for instance, p.name starts with t, and then I can just return p.name here. So it's a subquery kind of like a list comprehension. It's a pattern comprehension, so you can have a pattern, a filter if you want to, it's optional, and then an expression that does something at the end, and you get a list of the things that you have in your expression at the end, right? So so if I use this, then I basically get the same, just as this is executed as a pattern comprehension, right? So, and we don't have any person's name starting with T. That's really unfortunate. So let's see. Oh, okay. So we have people with O in their name, right? Okay. So if you compare the two queries in explain or profile, then you should also see the difference. So this is just in regular expand and then an aggregation, and that's it, right? So the regular stuff that we could have done in Cypher 5 years ago or 7 years ago. So pattern comprehensions was added in 3.1, as I said, and you see that it has this weird expression here with projection of an pattern comprehension, basically, and so this is like an eager aggregation goes into this projection, which is then internally doing an expansion and stuff like that, right? So this is kind of pattern comprehension. But if you wanted to take our first query and this one here, and rewrite this as an subquery, then we could say core, and then we say with m, because we want to use our movie, right? And then we do our match and say where p.name contains O, return p.name as name, limit 2, so at most 2. So you can do everything that we want in this subquery. We can of course also format it nicely so that it's multi-line, but I'm too. So it basically should have a name thing now here, and then if I do it like this, it should actually work. So right, let's try this. Yep. Right, so we get at most 2 actors per movie now with this. So pattern comprehensions can also, subqueries can also be nested. We could also say we collect inside here, so we only get the list back and return cast here, and then we just return cast per movie as such, right? Which now is a different semantics. As you can see, we have more than 2 movies because I messed up the limit. So with p.name as name, limit 2, return collect as cast. Right. Or I could have done collect name this, but then of course it's not as efficient because it collects first and then does the slice. And so now we should be back at our 2 names per movie thing. So, and the most important thing to remember about the subqueries is you have to declare the variables it uses at the beginning, like you used to do in C in the old times, or Pascal or so. And if you return a variable that already existed before, you have to rename it first, right? So you can't overshadow variables from a subquery. So that's super powerful, especially for more complex query generation. Kin asking about data limitations in Neo4j. So Neo4j has 2 modes. In the default mode, it's 38 billion nodes and relationship and 68 billion properties. And in the high limit mode, it's bunch of trillion nodes and relationships. So it's like 60 bits for IDs, I think. So that's kind of the current limitation. So the other thing that I wanted to show you here, so that's kind of the subquery thing, which I find really, really cool and useful, and I'm looking forward to add this to GraphQL and to SDN. Something else that was interesting, which I only learned about this morning, is that my colleague Chris West said that there were also improvements in the indexing, full text index. So if you create a new index, db create full text create node index. So imagine we want to index our nodes here, and we want to index, give them a name like search or so. And I want to index person and movie. And as properties, I want to index basically name, title, and tagline. Come on. So I hope I didn't change anything. You can also do like custom analysis and stuff like this. So let's see if this worked. Cool. And then we can do a call db index full text query nodes. And the new things is the new syntax allows for skip limit and things like that. And the scoring is also improved. So I, for instance, can say, in the old times I could say just our search index, and I want to search for MA. So something with Matrix or Mario or whatever. And I could get query nodes. I have to do MA star. Yeah, so you see I get, this is my node that I get back, this is my score, because Bicentennial Man, Marshall, Madonna, and so on, right? If I search for MAT, then I get other results, right? So how well does this basically score as well, right? So matrix here, for instance, right? And what's new in this is, so this returns how many results? 19 results here. And here now we can put in a skip, 5. And then we should only get 14 results, and the first 5 should be skipped. And then I can pass in a limit of 3, and then I should only get 3 results back. So, and this is actually passed down to the underlying engine, and should help you a lot, especially if you have lots of results. Let's say your full text index returns like 1 million results, or 10 million results or so, but you're already only interested in 100 or so, then it gives you the top scored ones. And also the scoring is now improved across segments of indexes. So Chris did a really good job there. What else did I want to show you in 4.1? So we did the memory management. Oh, we wanted to look at the pools and stuff. So remember when we have the queries and dbms list queries. So we see in the query listing memory usage. So we see allocated bytes here, and we also see in list transactions with S, of course. We see this allocated bytes, allocated direct bytes, so off heap memory and heap memory, and also estimated heap usage as well. And then if you do call dbms list pools, we see like all the memory pools that Neo4j has internally and how much memory is used of these pools, and so that also gives you for operations a little bit more insight here as such. So I hope that's something that, for instance, Halen will be able to use to chart memory usage in a good way. So that's kind of a little bit of more of the memory management stuff. So that's this. Okay, what were the other things that I wanted to look into? We looked at the role-based security, database privileges for transaction management is kind of granting to allow to list and kill transactions. So I don't know if you've not seen this. You can do call dbm as kill connection, kill transaction, and kill query, and basically you get a transaction ID and connection ID or a query ID with list queries and list connections and so on. So you basically can say, if you look at this here, you see here at the beginning, you have a query ID. Here at the beginning, you should have a transaction ID. And transaction ID, and then you can use these IDs to kill a query, kill a transaction, and kill a connection. So if I, for instance, list connections, I see all the board connections, and then I can basically also kill them if something long running is blocking those. Actually, that's an interesting one. So for instance, if I go to my Cypher shell here and do call epoch util sleep 10,000 or so, and if I go to my browser and rerun list connections, I should see one in Java, right? And that means if I do call dbms kill connection and pass in this connection ID, connection found, and let's see, and it has been killed. Nice, works. And so the other thing is that we are also able to control this and see how much it uses. Control F, Command F. Sorry, homeschooling. So public role, we looked at this, user management privileges. You can also kind of control who can manage users. Public role, we looked at the show improvements. Rolling upgrades is quite nice because if you run a cluster of Neo4j, you can run it with 4.0 and 4.1 instances at the same time. And only at the end, when you upgraded all instances to 4.1, then you can call a procedure and it will switch to 4.1 mode, basically. Memory management, we talked about this embedded Corso cluster, so embedded applications can participate now in Corso cluster. Leadership control is when you have a Corso cluster and you want to enforce that a leader steps down, for instance, you can now trigger this. And this is also used for instance, if you have to shut down an instance, you can force the leader of a cluster group to step down and hand over control. But that's also used for balancing. So now with multi-databases, each database has its own leader in a cluster. So you can basically distribute leadership of the databases over multiple instances. So if you have like 3 instances, you have 9 databases, you can kind of ensure that each machine has 3 leaders running, basically. Oh, query replanning. We haven't looked at query replanning. So that's actually something really interesting as well. I just tried to remember what the syntax was. Cypher, replan, skip or never. Let's see if it complains. Always. Replanning. So we need to look at the docs. Neo4j for documentation, replanning eyes. Let's see if Google can also help us with this. These are all the pattern, cipher, prefix, call. By the way, here is like call procedure, call subquery, things like that. Functions, administration, tuning, query options. So you can do Cypher runtime, interpreted, slotted, pipelined, replanning here. So usually Cypher has a query cache, so when it gets a query, it basically has to parse the query and then plan the query into a logical plan, into a physical plan. That's what you also see with explain and profile. And then execute the query, but also this kind of compilation of the plan is cached. So when it sees a query coming by that has exactly the same like string, then it just pulls it out of the cache. That's also a reason why you should use parameters in your Cypher statements. So it always looks the same and you only change the parameters, so you don't need to replan and reparse the query. But of course, if the data in the database changes, that might cause a better plan to be necessary. So it replans if a certain amount of data has changed, but also only after a certain time has changed. So there's like cache size and plan interval, and divergence is the statistic, so how many elements exist of a certain label, relationship type, or stuff like that. And sometimes you want to enforce or always skip replanning. So for instance, if you have a really low millisecond or nanosecond SLA that you have to ensure, and you never want replanning to happen, then you can use replan skip. Of course, only if you have parameters in your query, otherwise it's kind of pointless. So that allows you to have like consistent query performance without spikes in the SLAs. And replan force would kind of force and replan, so that means it will always replan this query that you can basically use to ensure that this query uses the latest like database statistics and stuff like that as such. Right? So that's so replan force is the syntax, not skip and not always. So I can say replan force. Then it would always replan basically the query. Yeah. Okay. So as it said here, when you have high load, you don't get latency spikes. Okay, what else did we have? Explain profile output. We looked at the tables, database routing. I showed you like the routing of, if I'm in movies, I can do show databases, right? So it's basically internally routed to the system database. But what you can also do is I'm now in the movie database, I can say use Neo4j match and return count star. So I can from within a database use another database as well.
which is also possible. So I'm connected to movies, but I actually query the Neo4j database here. Database router, so this kind of backend routing also allows you to use multiple use statements, one per statement, but multiple in a single transaction. But you can have at most one database that you write to in a transaction, not multiple databases in the same transaction. Read-write routing, so if you have a cluster and you send accidentally, for whatever reason, a write query to a follower, either because the cluster switched around or you addressed the wrong instance, or you actually use one of these use things while talking to a read-only database, but you use a write database or the other way around, then it routes the write query, for instance, to the read-write instance. And actually, that's an interesting aspect because this is an example here that I have. Where's my code? Where's code? Is this here? So here I have an example of Python driver 4.0 test that connects to a Neo4j database, right? And as you can see here, it uses a read transaction, right? So it says I'm reading, and it just finds friends of Alice and people, right? So if I just use these quickly. So what I can, for instance, also do is I can say create database people, and then say use people. See, I'm in movies, but I can see use people, and then create Alice, person, name Alice, and then knows person, name Bob, right? So in the people database, I now created like two labels, and so if I go now to people, I have here two nodes and one relationship, right? So, and if I now do my Python query, so you see Python 4.0 is only compatible with Python 3, so be careful not to accidentally, like me, mess this up, and then you're kind of wondering why it's not working. You can select databases, which is really nice, so multi-database support, and also some other stuff supported, like fetch size and stuff like that. So you can also pass in, I think, batch size or something like that here. And so if you run this actually in a Python shell, somewhere here I got in Python shell, I think, well, here. So this is Python 3. I installed Neo4j driver, so pip3 install Neo4j driver. And if I run this now, I see Bob printed here, right? But this is a read transaction. So if I made a mistake in my query and, for instance, say here is an let's say set f dot foo sneaked in for whatever reason, which is would be in write. In the past, this didn't fail, but now if I run this again, it actually fails because it says attempted to write to an internal graph people while writing access mode is not allowed. So this database routing thing that checks if where does the query have to go also helps us with this. So finally, these things are now also taken into account, and we can't accidentally write anymore to a database that is read only. Sorry, we can't write from within a read transaction, which is quite nice. Okay. The other thing, bold config, yeah, things like that. It's not so. Oh yeah, there's a keep alive in bold now, so you can configure bold to keep to send a keep alive from the server side, which your bold driver ignores on the client side. But that's used for load balancers that kill connections. For instance, if you start a long running operation like an import statement or an query that takes longer to compute, then the connection is not killed by a load balancer. Okay, anything else? Full text, full pass through, inline level, detach, delete. Fine-grained write, we already talked about this. Neo4j admin copy. By the way, if you haven't seen that, Neo4j 4.0 introduced Neo4j admin copy, which is the replacement for my store utils command that can copy databases, and while copying databases, it can also skip relationship types, labels, nodes, and properties, and so it helps also you to reorganize and repartition, defragment your database as well, and it can also skip broken records as well. And now the lawnmower man has started to mow the lawn on slide. Great. Time units, label records, db ping is a new procedure that you can check if the database is there, new transaction management, hash join, all privileges, system graph, kind of all these RBAC improvements, database management, better plan description. You can you can show your own privileges. So you can have what privileges do I have can now be quickly be visible. Auto user, show roles, lots of security stuff. Remove elements, packaging, epoch will be in 4.1. Public role, cursor cluster, new metrics, and bunch of browser improvements as such. Okay, I guess that's all from my side. I hope this was useful and you can make use of these new features in Neo4j 4.1. Super. As I said, I already pasted it into the chat, and I'll also add it to the YouTube video as well, or have already added to YouTube video as well. Okay, cool. Thank you all for watching, listening, and hope to see you next week. Take care, everyone. Bye.